Let us solve for x and y in this problem. X squared minus y squared is equal to 12. Looking at the expression on the left hand side, you can easily see that this is difference of two squares, and that can be expressed as x minus y times x plus y. So this implies that x minus y times x plus y is equal to 12. If you look at 12 itself, it can be expressed as a product of 1 and 12, or negative 1 and 12. We can also express it as a product of 2 and 6, or negative 2 and 6. Or we say 3 and 4, or negative 3 and negative 4. These are the only three possible combinations for 12 that we can have. Now, if we equate x minus y times x plus y to each of these products, it will mean that x minus y is equal to whatever the first is, and then x plus y is equal to whatever the second is. But how can we decide which is the first or which is the second? If you look at the sign in the middle of this expression here, it is negative, while here it is positive. It simply means that the first expression is less than the second expression. That is, x minus y is less than x plus y. So whatever we are going to change 12 to should be in an order such that the lowest factor comes before the higher factor, which coincidentally seem to already be arranged for us in the positive factors. So let's try each of these factors out and see how we can solve for x and y. So I have x minus y times x plus y is equal to 12. I'm going to start with the first product, which is 1 and 12. So like we said, this will imply that x minus y is equal to 1, or x plus y is equal to 12. So for this first combination of factors, let us solve for x and y. So this first one, I'll call it equation 1. This second one, let's call it equation 2. So if we add up equation 1 and equation 2, it means we now have x minus y plus x plus y. And that's 1 plus 12, which is 13. If we tidy up the left hand side, we have 2x is equal to 13. Divide both sides by 2 gives us x is equal to 6.5. So we say 6 whole number 1 over 2. Now let's put in the value 6.5 into equation 2 here to get corresponding value for y. So it means 6.5 plus y is 12, and then y is going to be 12 minus 6.5. Y is equal to 5.5. Or we say y is equal to 5 whole number 1 over 2. So this is one way to solve, and if natural values are not expected, this is actually an acceptable solution. But there is a limit to our answer. The condition given is to obtain a natural value for x and y. So if that is the case, we might not go ahead with this solution. We will need to test further for another set of factors. The next in line will be this 2 and 6. We have x minus y times x plus y is equal to 12, and 12 is now 2 and 6. This implies that x minus y is equal to 2 and x plus y is equal to 6. Let's add this together and solve simultaneously. So we have 2x is equal to 8, and if we solve for x here, we see x is equal to 4. Going back into this equation, x is 4 now, so we say 4 plus y is equal to 6, meaning that y is now 6 minus 4, y is equal to 2. This looks like a very good solution because it's both an integer for each of them and also a natural number. That is, they are not decimal numbers. But let's test the last one before we conclude. The next factor to test are 3 and 4. Let us test out 3 and 4 and solve respectively. We have x minus y times x plus y is equal to 3 and 4. Remember, the 3 must always come before the 4 because the first bracket here is less than the second bracket here. So we equate x minus y to 3 and x plus y to 4. As usual, if we add up the two equations and then subtract to solve simultaneously, we see 2x is 7, and solving for x gives us 7 over 2, which is 3 1 over 2, or 3.5. And if we put the value 3.5 back into equation 2, we see 3.5 plus y is 4, and solving for y will give us 0.5, or 1 over 2, which is also not a naturally occurring number. So like I said, if what is expected is a natural number, then this solution is also not accepted. So we've tested the 3 possible combination of factors, and we can now confirm that only these two, x equals to 4 and y equals to 2, are accepted solutions. Please give this video a thumbs up if you have enjoyed watching it. Subscribe to my YouTube channel, and I'll see you in my next video.